अरे क्या रे? व्हाट यू आर डूइंग? ओ अम्मो। अविनाश, भुवन, दीपक, हर्षिनी, जयंत, मनु, नागराणी, निकिता, रानी, श्राव्या, श्रीकांत, तिरुपति, उत्कर्ष. You are not maintaining even pass marks also. Out of 100, what is the pass mark, Avinash? 32. 100 का 32 पास मार्क है क्या दीपक? ये तुम्हारी जगह 32. साढ़े क्लास का वाला है. अरे Saturday class decided by management only. Management want declare holidays, no class. If holidays are from Sunday, then class. Why you are not doing the assignments? What is the problem, Shravani? నీ పేరు లేదు ఇందులో. Become lazy. వెంకీ, అసైన్మెంట్ ఏది చేసావా? వెరీ బ్యాడ్ స్టూడెంట్స్, నాట్ గుడ్ స్టూడెంట్స్. Nowadays, my situation is like kind of a one-side lover. Okay. Whether you love or don't love, I will love always. You do assignment, don't do assignment. Every day I will give the assignments. That is. That is my situation. At least show some love. Okay. At least pass marks. 35. 105 members are there in the class. Very bad. If I wait for you and will not able to finish the syllabus. Huh? If I wait for your assignments. So go to next what? Go to hell. Whether you do assignments or don't assignments, I don't mind now onwards. Okay. Srikanth, because we can't finish the syllabus if you do this kind of things. If I wait for you, you do that. So next algorithm is called decision tree. Decision tree. The name itself saying that tree. So it is like kind of a tree structure. It is a kind of tree structure. So in tree, what we will have in tree generally? Leaves we have, branches we have, roots we have, nodes, roots, branches. Leaf, branches, and roots. The name is saying that so generally it will start from one starting point and it will go like this, okay, and it will go like this two ways, and again here it will divide like this, like branches, And again, some more branches like this, branches. And finally, it will reach to output. Yes or no, yes or no. Like finally, it will reach the output. Before going that, what happen is, now you start with this. This is the, you start with this point and you'll go down, you'll separate into two ways, suppose. Separate into two ways. So the starting point is a leader. The starting point is nothing but a leader of the house. That we call is called root node. What we call is called root node. Root node. There are so many might be variables will be available. Maybe age variable, gender variable, age variable, gender variable, income variable. Out of these three variables, who will become the root node? Who will become the root node? From which variable you will split the data? So that is the important point in the decision tree. Okay, decision tree is generally a tree structure. Tree structure means you need to split the data. So you need some starting point. Starting point is nothing but which variable is become a root node. The question is what here? Which variable is become a root node? Which variable becomes a root node? You see here in the PPT will be like this. So in the decision node, it will be click like this. Again decision node, again decision node, decision node. Decision node is nothing but variable splitting process. Variable is splitting. You will reach to leaf. Leaf means outputs. Leaf means output. For every data, you have one output will be there, right? Every sample. That is either yes will be available or no will be available. So these leaf nodes are yes and no kind of thing. So, but you need to understand what is your starting point. How can you want to split your data? How you want to split your data? That is the first question. How you will split your data? How will split the data? To split the data, to split the data, to split the data, will take a help of, a variable, and that variable is called root node. Root node. So this root node is the very important. Root node. That means it's simply you want to make one leader. You want to make one person as leader. One person as leader. That leader should be has. What is the first quality of leader? Tell me. Aggression, calmness, focus, dedication, patience. There are two types of leaders are there in the world. Generally, in the past, if you see, one is Ashoka Chakravarti, you know, Ashoka. And another one is, you know, Tughlaq. There are two leaders out there. What Tughlaq will do? What Tughlaq will do? Generally, will scold one person, right? Nowadays, what Tughlaq? Generally, what Tughlaq has done? Why he become a bad emperor? He changed the decisions. He changed the decisions very frequently. He's not able to stay on one part decision. That means a guy has more randomness. More randomness. He cannot be a good leader. He cannot be a good leader. A guy has less randomness, which means more focus, more focus, more focus, then he become a good leader. That idea will take. That idea will take. So this, now the story will become as randomness story, randomness. The story leads to now randomness. Now there is a scientist called Shannon. Shannon. Bolo, how many are electronic students? Electronics and communications. Electronics and communication. Shannon information criteria. Shannon information criteria. Shannon information criteria. There's a guy scientist called Shannon. Shannon information criteria. Shannon, that we call entropy information theory. The information theory he published in 1948 due to World War II. At the time of World War II, what happened? He created a equipment. So your information is valid information or not to identify that. You're getting? Information is a valid information or not. That is called information theory. That concept is called entropy concept. What the concept name is called? The concept name is called entropy. So it is look like this. The concept name is called entropy, concept name like this called. Suppose Ramesh and Kumar are best friends. Best friends. Now Ramesh has a family function. Family function in 2 days. In 2 days. For that function, both Ramesh and Kumar are working together. Working together. So naturally, one day, Ramesh called to Kumar. Then what Kumar thinks about that call? Hello Kumar, what do you think? They are working together, no, for function related. So one day I called you. Suppose I am Ramesh. I called to my friend Kumar. So what Kumar will expect? Huh? Invitation? Invitation or some other work? Invitation or some other work. So here, no clear. So Kumar knows. Kumar knows why Ramesh called. Why Ramesh called. Correct? Now suppose one day, suddenly 1 a.m. Kumar has some missed calls. Okay. Kumar has some missed calls about Ramesh. Now what Kumar thinks? Same perspective? Definitely not. Drinking. Drinking perspective? Definitely not the same perspective. Correct? So, which call has given the more randomness? Which call has given the more randomness? First call or second call? More randomness. Second call, no? Suddenly our parents are called at night 1 o'clock, what will panic ho jayega na? Why is calling this time? What happened? And he's not lifting the call again back. So more randomness. That means here is the less randomness because you know the output, you know the straightforward, the information you already know. already know. And more randomness, more randomness, more randomness. That information you doesn't know. Information you doesn't know. This is one scenario. Let's take another example. India versus Zimbabwe match. Who will win? India. More randomness or less randomness? Because you know the information. India versus Australia. 50-50. Then, before 1 month only, you will talk about this information, no? From starting 1 month only, what will happen? Virat Kohli century marega kya? Rohit Sharma, captains will be there. Who will be the good bowler? Like how Cummins will bowl, how Max will do. All you will talk. That is. That means more randomness. Whenever you don't know the information, that is a more randomness. Whenever you know the information, less randomness. Ultimately, you need Ashoka Chakravarti, not Tughlaq. Okay? So Tughlaq has more randomness. Ashoka has very focused. That is. So this idea he has given, this Shannon has given. This Shannon has given now value of the information. Value of the information is related to some randomness. And that randomness is a concept leads to concept called entropy concept. Concept is called entropy concept. Entropy concept. So now you see, right, whenever some politics are going, so which party is coming to rule, you already know that. So nothing much interesting news, right? That is. So that is a less randomness. You don't know which party will come. Maybe Hung will come kind of thing. Then you'll talk more. More randomness, you'll talk about more thing that is. So that means you doesn't know about information. So you need to think like this. You doesn't know about information. You does not know about information. Then you have more randomness. Then you have more randomness. When you have more randomness, your entropy is more. That is the logic. Entropy is more. Entropy is the more. You doesn't know about information, you have more randomness. Entropy is more. So now, what is the entropy formula? Now, what is the entropy formula? Let's put aside now entropy. Entropy formula now. Entropy. Entropy. Tell me, Deepak, entropy formula. Huh? Summation P log P. I 1 to N I H. Entropy denoted with H. Minus Pi log Pi. Minus Pi log Pi. And I'll just provide the graph inside, then you'll understand that is. So this is probability 0 to 1. 0 to 1. You already know 90% India will win. That you already know the information. So less randomness or more randomness? Less randomness, entropy will less or more? Less. So entropy will be low. Okay. Suppose you already know the same other case. One, you already know probability 10%. Other means other automatically what happen? 90%. So either 90% or 10%, your randomness is what? Less only. Randomness is less means entropy will be less. When you have a 50-50 chances, exactly, then entropy will what happen? Maximum. So if you attach the graph will be look like this. The graph will be look like this. So if you are middle, your 50-50 chances, entropy will what happen? High. You already know, you already success case, you already failure case. That means the outcome is already presented. Then entropy will what happen? Less. And that entropy image like this. This is the entropy symbol. Okay. Entropy symbol. So it is low, low, high also low. Only in middle what happen? That entropy will be high. Entropy will be high. And this is the formula. Note on the formula. Minus pi log pi. Minus pi log pi. Minus pi log pi. Here base equal to 2 because information will go in the form of bits. Information will go in the form of bits. The base equal to 2. Information in form of bits. So the base equal to how much? 2. Logarithmic base is equal to how much? 2. Log base 2. Log base 2. Log base 2. Information in form of bits. So the base equal to 2. Clear? Entropy formula. So more randomness, more entropy. Less randomness. When you will get more randomness, when you doesn't know about information. So that guy we don't need. We need a guy as a proper information. That means less randomness. So finally, who will become the root node? Which are having the less entropy. So who will become the root node? The root node has less randomness. That means less entropy. Less entropy. Let's do a simple calculation. Toss a coin. We'll see. We'll do that. That entropy really 1 for toss a coin. Toss a coin is the more random or less random? Toss a coin. What is the output? More randomness, right? We don't know what is exactly output. There are two probabilities. Toss a coin will give either head or tail. Now write the probability. Probability of H. Probability of H, that is equal to 0.5, and the probability of tail, that is also equal to 0.5. Now there are two outcomes. Come to write this entropy formula now. Entropy equal to now open this bracket now. That is, there are two outcomes. That n is equal to how much now? N equal to 2. N equal to 2. So this is the first term. This is the first term. This is the first term, and the second term, and say minus, that is equal to H equal to. So this is P1 first term, and this is first term. This is second term, and that is also second term. So here first term means H. First term means what? H. Another one is what? Tail. Two probabilities, right? Two outcomes, that's why n equal to 2. Two probabilities, one probability is equal to h, and this is also h, this is tail, this is also tail. Now substitute the values now. Substitute the values. Probability of h is equal, that is equal to 0 minus 0.5, minus 0.5, and this is also 0.5, and this is also 0.5, and this is also 0.5. So this is entire is 1k, it is also k, minus k, minus k. What is this entire thing? Is look like same? This entire term, this entire time, both are same or not? So indirectly it is look like minus k, minus k. It will look like this. Agree with me? Both are same terms, na? This 0.5, this one term, and this one term, both are same terms. Both are same terms. That is minus k, minus k. What will happen? Minus 2k. Then what will, how can you write this now? Minus 2 into like this. So minus 2 into 0.5, how much? 1. So what is this now? Minus like this, correct? Now what is 0.5? What is 0.5? 1 by 2. 1 by 2. So 1 by 2 you can write like 2 power minus 1. 2 power minus 1. Then minus 1 come like this. That is equal to minus 1. And this become now 2. Log 2 to how much? So what is the entropy answer? So more randomness. What is the maximum entropy? 1. That's it. Hence proved. Hence proved. I will repeat again. See here. So this is the formula. So we are applying a toss a coin. Toss a coin will give two probabilities. One is the probability of head and another one is the probability of tail. First expand this. I already taught you how to expand the summation, right? So two outcomes, P1 log 2 P1, P2 log 2 P2. What is P1? Probability head. What is P2? Probability tail. Substitute the values. 0.5 log 2, 0.5, 0.5 log 2, 0.5. So 0. This is a 50 paisa, this is a 50 paisa. 50 plus paisa plus 50 paisa, 1 rupee. So that is a 1 rupee here. Now 2 into log 2, 0.5. 0.5 kaise likhna? 1 by 2. 1 by 2 kaise likhna? 2 power minus 1. In logarithm we have a rules are there. What is the rule? Log of a power m equal to m log a. M log a. That is the rule. That is the, so the rule number 1 in the logarithm, you can write like this: log of a power m equal to m log a. That is the one rule. And one more rule is log of a power a equal to 1. That is another rule. And we have one more rule is there. 1 by a equal to a power minus 1. This is one more rule. There are 3 rules in mathematics. So that's all. Hence proved it is. What is the sigmoid formula? 1 by 1 plus e power minus x. In the same way, logistic regression, you need to remember that formula. In decision tree, you need to remember entropy formula. What is entropy formula? Minus summation pi log pi. That you need to remember. Simple formulas. Simple only. It's not total entropy. Which one, ma? That is total entropy. Maximum. Directly to take the total entropy, it is maximum. Not one. The maximum. Okay. Here in the case maximum, because it is a more randomness. Toss a coin is a more random case. That's why it is a maximum one. But if you do the same approach for all the probabilities in the case, always you will get the maximum value. Always you will get the maximum. That you are correct. Understood now? Now shall we do one more problem now? How to find the root node? Put heading. Can you please confirm the chat, ma? Good, right? Entropy? Nikita is good. Srishti is good. Priyanka is good. Arun is good. Very good. Now to how to find the root node? How to find the root node? Before going to find the root node, now everyone please note down these 14 observations. Note down this first. Note down this. Note down 14 observations. At least ID, age, and by the computer. That you note down. Not required all. At least you note down this. And ID, age by the computer. That is. And youth, middle age, senior. So this is youth, middle-aged, senior, and again middle-aged. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And by the computer, no, yes, no, yes. No, yes, 3 yes, and again no, again yes. And similarly, I need more. 8, 9, 10, 11, 12, 13, 14. So 8, 9, 10, 11, 12, 13. Final one is the 14. So 8 से शुरू होना YYSY. Y, yes, Y, and middle-aged, and senior. And this from 8, no, 5 yes, and no. No, yes, no. Note on this. Only age and one column is enough. We'll find mathematics for one column. No need to do for all. Anyhow, Python will take care of. We need to understand that how the mathematics will works, right? That is for one column is enough. Noted? Venki, which movie are going? Guntur Karam not going. Going. Sankranti means Pongal means movies. Movies means Pongal. In childhood, Pongal means Muggulu Potila. Kites. Kites, Rangoli, movies, back to back movies, 3 days in ETV, Gemini, colors. And how can you forget that? Snacks. Snacks also, no? Sankranti Pongal means snacks. So how many are going to home? All are going. No, all are going home. So let's start with age. So, so age is divided into how many parts? Age is divided into how many parts? Bolo, what are that? Youth. So youth, middle aged, senior. Senior batch students, you people are in RHIT. How many observations are there? How many youth observations are there? Tell me correctly. How many middle aged are there? Char. Senior? Huh? Hey. Okay, this guy. Youth, middle age and senior. Okay? Then again. Yes and no. Yes and no. Yes and no. How many? Three, huh? Three, no? So 2 and 3. Here middle-aged 4, comma 0. And here senior 3 yes, 2 no. Out of 5, 2 are yes. What is the probability? लिखो 2 by 5 लिखो इधर. Out of 5, 3 are no. 3 by 5 लिखो इधर. 4 by 4 लिखो. And 0 by 4 लिखो. And 3 by 5 लिखो. 2 by 5 लिखो. Out of 14, 5 are youth. Huh? Middle-aged? No, it is not there. No, no, not there. अरे क्या रे तुमको. Priority, 1 minute, huh? Security photo. Hey, Sanjay. Yeah, you are noted right now. Entropy of H, that is H of H, H of H, H of H equal to combination of H of youth plus H of middle aged plus H of senior. H of senior. Now H of youth. Now take H of youth. Now take only H of youth. H of youth equal to, in the youth, how many are there? Yes or no is there. Again, how many outcomes are there? 2 outcomes. So same formula. P1, P2 formula. This is P1, P2 formula you need to write, because how many outcomes are there? That many outcomes you need to write. Same. That means here it is nothing but S case, S case, and here also S case, and no case, and here also no case. Similarly, H of middle aged also same thing. H of middle aged also same thing. And H of senior also same thing. Because only two outputs are there, right? S and no. Give me 1 minute. Yeah, write it, ma. Write the values. Write the values for everything. Give me 1 minute. They need my photo and they are rejecting every time. Google wala. That is. We'll call again. Give me 2 minutes. So write the values. So what are the values here? You write it. I will be just in 2 minutes. Okay. तो क्यों करना है? अरे नियर आसपास में कोई फोटो स्टूडियो है क्या? किधर है फोटो स्टूडियो? आसपास में कोई फोटो स्टूडियो है क्या इधर? किधर? सीधा सीधा जाना। ओ, मेन रोड के पहले। अरे वो दे आर रिजेक्टिंग बार बार. So I'll go to studio, I'll take nice picture and I'll upload. They are bar rejecting that. What is the value here? I don't calculate output, okay? Just write it. Don't calculate it. Don't calculate the probabilities. That is not your job. Python will take care of. What is the value? 3 by 5, huh? 2 by 5, huh? Don't calculate 2 by 5 is equal to 0.4. Okay. That is unnecessary. Anyhow, Python will take care of that is. Now what is the P? No. 2 by 5 again. 3 by 5. And this is 3 by 5. And P of S 4 by 4 by 4. 4 by 4 लिखो. 0 by 4. And this is also 0 by 4. And this is how much this is? 2 by 5, huh? 3 by 5. 3 by 5. The next 2 by 5. 2 by 5. So this is the equation. And this is the equation and this is the equation. ठीक है. Now substitute here. Now tell me this. Again, same question. Same question. Is this equation correct equation or wrong equation? हाँ, सौरव बोलो again once again. Correct equation or wrong equation? ऐसे कैसे करेक्ट? ऐसे कैसे करेक्ट है तो देन व्हाई दिस इक्वेशन रॉन्ग? व्हाई दिस इक्वेशन रॉन्ग? व्हाई दिस इक्वेशन रॉन्ग? If that equation correct, then why this equation wrong? बोलो. You can't add anything like that directly, okay? In this entire data set, youth, middle-aged, senior are equally part. No, right? So there are three different equal contribution is not there. Different contribution is there. So the different contribution, what you will write here? Weightage. So it is W youth weightage into, and here W middle-aged weightage. Middle-aged weightage. Weightage concept is very important, ma. Weights concept. And W senior. W senior. So W youth, W middle-aged, and W senior. So the equation will turn out like this. Now you need to find out W youth. W youth equal to out of total contribution, how many are the youth contribution? Out of how many are there? 14 are there. How many are there out of 14? How many youth are there? 5. So 5 by 14 is the this weightage. 5 by 14 is the weightage. And similarly, W middle-aged. W middle aged. How many are there? 4. And similarly, W senior. W senior is equal to how many? 5. So finally your equation will be like this. 5 by 14. 5 by 14 and 4 by 14 and 5 by 14. 5 by 14. 5 by 14, 4 by 14 and 5 by 14. And you can substitute your equation, every part. What is the h of youth? Substitute that value here. This is h of youth. Multiplication is the first part. Square bracket plus second part. This is the second part. Middle aged. The second part. One thing you can calculate, but there are so many calculations are there like this. So that's why it is not a good idea to write the entire calculations. This is enough. Idea is enough. How the internally the maths will work is enough. So these are the three values.
ఇయ్యాలనా సిమెంట్ తెచ్చినవా
There are the three values. H of age equal to. Clear till now, everyone? Next step 2, total entropy. Put side in total entropy. Step 2. Total entropy. Total entropy. That's the step 2. Total entropy means number of S in total in data. Number of S. Number of S. Number of S equal to 9. Number of no equal to 4 in entire data. Entire data. Correct? How many S in entire data? How many S in entire data? 9. Correct or wrong? Then no 5. Huh? So P of S. So P of S equal to 9 by 14, comma, P of no equal to 5 by 14. Again, same entropy formula, same. The formula is not changed. The formula is changed. Total entropy again. Total entropy H. Total entropy H. H equal to same. Total entropy. Entropy formula is always same. Only the values will be changed according to that. 9 by 14. 9 by 14. 5 by 14. And that is a 5 by 14. The step 2. You need to calculate the individual entropies and you need to calculate the total entropy. Individual entropy we calculated for H, correct? And also we calculate the total entropy. Like that, we will calculate the individual entropy for how many other variables are there? We'll calculate individual entropy. Individual entropy for what is the other variables? Entropy of what is the data in the data? Income. We need to calculate the entropy of income as well as we need to calculate the entropy of student by computer's output, na? Entropy of credit rating. In our data set, we have total 4 variables are there. In our data set, we have all 4 variables are there. What are the variables? Age is one variable, income is another variable, student is another variable, and credit rating is the another variable. Out of this, one variable become a root node. One variable become a root node. That's why what we calculated for H of age, H of income, H of student, H of credit rating. You need to do this, but not required. You know how to do for one, right? So not for all. Okay. So we'll do like this. We'll calculate it for individual entropy for H of income, H of student, H of credit rating. Already we calculated for what? Age. So in step 3, what we'll do? We'll calculate the information gain. What is that? Information gain. Information gain. So information gain means H of your variable, subtracted from the total entropy, that is equal to H of T. I can write H of T total entropy minus H of entropy of that variable. Entropy of that variable. That means information gain of variable. That means we'll get all 4 information gains, correct? Information gain for age will get. Information gain for age will get. What is that age? H of total minus H of age. And similarly, information gain for income, then H of income. And similarly, information gain for student, then H of student. And finally, information gain for credit rating, and that is equal to credit rating. H of total always should be maximum. That is always should be maximum. That is 0.9, 0.8, might be sometimes 1 also. Now, based on your idea, which will become a root node out of these 4? What is the idea here? Which one will become a root node? Less entropy, correct? Less entropy minus matlab more gain. less, not more information, that information gain is more. Less entropy matlab more gain. That's why you are subtracting, right? This is less means the total value will what happen? More. That's why that is called, name is called gain. So less entropy will, you can ask me the question, sir, why you are doing this step? From this step only we can conclude the answer, right? But this step only we can conclude the answer. Less entropy is the good root node. Why we are doing this step? Why we are doing that? Having reference is always important. I asked you many times, right? What is our famous question? 100 is more or 1000 is more? Huh? 100 is more or 1000 is more? 100 for 200, 1000 for 2 lakhs. Now which has more? 100 is more. The reference is very, very important. Referencing. That's why we are taking the information gain. Information gain. Everything is the gain. This gain is the, this is a different population. 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 All are bits, but the population is coming from different. So that's why we need to get the information gain. And this is a combination of all 4 populations same. Total yes and total no. That's why we need to take the reference as the information gain. So finally we know that, what we know that less entropy gives less random, and that is important root node. So less entropy means more information gain. Any doubts in this? Less entropy means more information gain. More information gain. In this, any doubts? Less entropy means more information gain. Everyone is good, right? So whoever has more information gain, that is your root node finally. Whoever has more information gain. So which variable has more information gain, and that become a root node. No. Here not target. Here individually in this columns age, income, student, credit rating, only these 4 columns. In that 4 columns, who is your leader? You know, you need to compare this age with this bias computer, that you need not compare. You need to identify the leader here. That means root node. That is the concept here. Don't compare with age with bias computer, income with bias computer, then identify. That is the important. That is again that correlation covariance. That is. Here we are talking about the information gain. You need to compare only age, income, student, and credit rating. Now tell me the steps, ma. What is the first step? What is the first step you will do? Step number 1. Calculate all individual entropies or individual variable entropies. Formula is same, minus pi log pi. And step 2, calculate total entropy based on overall labels. Formula is same, And step 3, calculate information gain. Information gain. And what is the conclusion? The conclusion, which having highest information gain, which have more information gain, that become a root node. So that is the logic. And you know how to do the mathematics calculation also. The total entropy is called 0.940 ma total, and age is equal to 0.694. The calculations are available in PPT. And gain is equal to 0.246. Similarly, 0.029. So these are the values. These are the values. Gain of age is equal to 0. I'll just write the values. H of total equal to 0.940. 0.940. And h of age equal to 0.694. 0.694. And the gain, information gain of age equal to 0.246. Similarly, we have all four. We have Don't try to calculate. Don't waste the time. Okay. And income value is equal to how much? Because calculation is not important here. Concept is important. 0.29 and 0.151 and 0.048. Which is highest one, ma? Which gain is highest one? Age is the highest one. So age is your root node. Here income, here what is the student? Student, here credit rating. So age is the root node. Story is not yet done. Picture abhi bhi baki hai. Asli picture abhi start ho. Story not yet down. Now age is your information gain. That means age will be like this. Now you started with age. Age. So now age will go divided here. When age is divided, what is the remaining data set? When age is gone, what is the remaining data set? From this data set, you need to remove the age thing. Again, under age is how many parts it divided? Youth, middle-aged, and senior. Now age and youth gone, what is the data set remain? Age with youth, what is the data set is there? Age with youth, income, student, credit rating. What is there now? A new data will be created like this. Listen very carefully. Income, student, credit rating. Now the observations are like this. High, no, fair. This is the high, no, fair. The next observation is age with youth. Again, high, no, excellent. High, no, excellent. And again, data set is medium, no, fair. See this. Medium, no, fair. Medium, no, fair. And again, one more thing is there. Like that, based on age, based on youth, the new data set will be separated. Based on age, based on middle aged, again one more data set is separated. Based on age, based on senior, again one more data set is separated. The data divided how many parts now? 3 parts. But each part, how many columns will be there? Only 3 columns, not 4 columns. Because already age is gone, right? Already age is gone. Understood, ma? Already under the age, under the youth, how many are there? Under the middle age, how many are there? Under the senior, how many are there? Like that, 3 data sets will be separated. Again, they will calculate the entropy for all these things individually. Again, they will calculate information gain. Again, entropy. Again, information gain. Again, entropy. Again, information gain. Again, out of these data set, they will find what? Root node. Again, that will be divided. Again, that will be divided. Again, it will be divided. Again, it will be divided. And will keep on calculate, keep on calculate, keep on calculate. Finally, at the end point, it will reach to leaf node. So many calculations will happen. Are you visualizing that? So many calculations will happen. Not only the story is not at all. This is only one level. This is second level. Like the third level, fourth level, fifth level, till until you will go to the last level. Stopping condition hyperparameter tuning आता. That is that hyperparameter tuning is there. Stopping condition that only. Suppose if you want to go to till last step, when you will reach last step? When you will reach last step, first you will get only one variable, na? First you will only get one variable. You'll keep on, you do that calculations only. This is called depth. What do we call this called? Depth. Depth is nothing but number of steps. Maybe how many steps your data set will go that you doesn't know that is. Maybe 10 steps or 15 steps or 20 steps. The more depth you go, the model will be more complex. In the linear regression, we have seen the complex, right? The more variable you add, that is the complexity. There, here, what is the complex meaning? The more depth you go, that is the more model will be complex. So the data set will be divide, again calculate, again divide, again calculate, like it will go on like the tree structure only. That is. Are you getting, ma? Can you please confirm the chat? Are you getting this idea? Story not yet done. Again, there is a asli story is there. It will keep on goes. Again, I'm repeating, ma. So you understood age is your root node. So age is your root node. Then age already become divided into 3 parts: youth, middle-aged, and senior. Here a new data set will be created. Here a new data set will be created. Here also new data set will be created. Here also a new data set will be created. In this new data set, what are the columns now? Income, student, and credit rating. Here also income, student, credit rating. Here also income, student, and credit rating. You will repeat the same calculations. Maybe you will find income is a root node here. What you will find here? Income is a root node here. Here student might be root node. Here credit rating might be root node. Again it will divide into parts. Again it will divide into parts. This time age and income gone. How many columns are there here this time? 2 columns. Here also 2 columns. Here also 2 columns. Again this will be divided and it will be stopped finally like here, like that. So that will be keep on goes. It will be keep on goes. That's why I ask you to don't solve the mathematics. Okay? Because you are at this position only. Will you solve all? Huh? That will take care of whom? Python will take care of. Python will take care of. So next we'll continue this. Still some more left is there. Concept is there. In left is there. It is not yet completed. But again, I will create the assignment today for this mathematics. Decision tree assignment. Because I am a one-side lover, you know. I'll keep on give assignments only. Whether you solve, don't solve. That is. Because you need to understand, right? You know, this is a mathematics is the three steps are there. The steps are there, the mathematics you need to understand. And this is the only demo I have given in Naresh Shetty, they selected me. They feel like that no one has taught this mathematics. When I given demo, all mentors are there. 10 members mentors are there. They selected me. Mentors are selected me as a trainer. They felt like that no one has taught this mathematics, sir. That is. Mathematics is important, ma. So these steps are important. You need to explain in the interview these steps. What is the approach? They will ask you what is the information gain, what is entropy concept. That everything they will ask you. Whenever entropy concept, what you will say? Say the story. What is the story? Kumar and Ramesh story you can say. India versus Zimbabwe story also you can say. That is more randomness. That is more information, more entropy kind of thing. Less randomness, less entropy. Create a story and explain in an interview. Then that guy will understand. He really learn the data science. Understood? Chalo. Thank you. Thank you so much. See you tomorrow.
ఆ పిండి ఏదో వాసన వస్తుంది.
క్లాస్ అయిపోయాక ఫోటో స్టూడియోకి వెళ్ళాలి అర్జెంట్. ఈవినింగ్ తొందర వస్తుంది 7కి అట్లా ఉంటా. ఈవినింగ్ ఉంటారా?
ఏమో అది ఆగిపోలేదు. అవును గమ్ముండు.